Hello, everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 1D. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 6th International Conference on Information and Communication Technology for Intelligent Systems through Zoom. Further, as you are aware, we have facing new normal situations while overcoming the pandemic, and the conference has been shifted to a hybrid mode. Further, we hope you will enjoy the knowledgeable and interactive sessions through the day. Also, there is a special note for the presenters. You will be given 7 to 8 minutes for the presentation and 2 minutes for the question and answers. On 7 minutes, I will raise a gentle reminder. And I request while the presentation is going on, other participants kindly be muted. There's another request to all the participants that you all stay connected with us till the closing remarks. And just before we get started, I would like to introduce you all to the chair for this session. Dr. Bharat Singh Deora. Uh, Dr. Deora has over 25 years of experience in the field of computer science as a faculty, researcher, software developer, and project guide. Presently, he is working as a senior assistant professor in Department of Computer Science and IT of JRN Rajasthan Vidyapit. Dr. Deora is also a life member of various national and international bodies like CSI, Computer Society of India, ISTE, Indian Society of Technical Education, IEEE, Institute of Electrical and Electronics Engineers, ACM, Association of Computing Machinery, IEEE Cloud Computing Community, and like there are many more. Uh, thank you, sir. Now, I would like to start with the papers. Our first presenter is P.K. Juneja, time delay, and his paper presenting on time delay compensator design and its application in process control. A review.
Should I start?
Yes, you can, please.
Okay. So the title of this paper is Time Delay Compensator Design and its Applications in Process Control. This is application of time delay compensators and in its application in process control. I am Professor Pradeep Kumar Juneja, presently working as professor in EC Department of Graphic Arrow University. So the chemical process industry, which we are talking about, is basically includes textile industry, pulp and paper industry, water purification plant. These are just to name a few. These are sugar mill, leather, cement, fertilizer, glass, oil, and there are many other industries which comes under the category of chemical process industries. So there, in these industries, in process control, we have to analyze this process with the help of the models because exact process cannot be known. So that time is always an integral part of any process. This wherever there is propagation of energy from one place to another, that time is an integral part of that. So the process industry commonly has first order plus jet time model, which is FOPDT, or basically second order plus jet time model, which is SOPDT model. So the easy implementation and operation of PID controllers makes it extensively applicable. Still at present also PID controllers are being used in these industries for control. So there are many challenges in controlling these complex processes. The challenges includes the process is multivariable in nature. There are more than one input and more than one output, and because of that, they are interactive in nature. They are counter interactive. It means whenever the interaction is not required, still they interact with each other loops. there is a presence of delay which is causing the complexity, and there is a large delay in comparison to time constant that is still you make this problem bigger, where the time constant is less and the delay is more in comparison. And then there is a process and model mismatch always, because whenever we try to make a model from the process, it is not 100% perfect. So that mismatch error is always there, and the exact process is not known. That is also a big problem. And somehow the process is being derived from some methods. So the challenges continue. There is a decoupling problem, because to design a decoupler is a challenge in the industries, so that the cross couplings can be removed or minimized. There is instability, non-linearity in the process. Delay compensation sometimes is not possible. The response is inverse in nature, and there may be a large order of the system which need to be modeled to a lower order system. So it is a common practice to model the process in the industries whenever there is a delay involved with first or second order delay process. It is a challenge to design process controllers for such processes in which there is a delay or there is interaction. It is not possible to eliminate the inherent process delay, but it is possible to compensate the effect of the delay which is present. So uh, this paper reviews what are the possible configurations and algorithms and types or methods by which the time delay can be compensated. And this strategy has been much used in at present also, and it is an advanced technology, and this paper is an attempt to review that application. So this we have already discussed. Now this is the literature survey, which is focusing on the applications of this paper, where uh, these literature survey has been framed in the form of a table after this exhaustive literature review, where around 30 to 33 papers are included. And these survey and their important findings are listed in the form of table, where we can clearly see that Giraldo et al. Has taken the process of crystallization reactor, which is a time delayed process, and it has used a Smith predictor, which is a predictor based technology, and which can delay which can compensate the delay to a certain amount, which is this has given well known technology with the help of which the delay can be compensated. Similarly, there are all these authors, Liu, which has also used crystallization reactor process and use the technology of predictor-based disturbance rejection control. In this paper, it has not only seen the effect of compensation of the delay in set point tracking, but also try to reduce disturbance rejection also. Similarly, there are other papers where the similar work has been done. For example, in paper number 18, where M. Yadav has selected a delayed process model, which is a blending process, and then dead time compensators has been used and designed using two different filters. Filter coefficients has been used to design this. We have also designed some compensators, for example, paper number 23, where I am the co-author, and also in paper number 26, where SK Sonori and our team has designed this compensator techniques using payday approximation for paper basis weight control in paper mill systems. Similarly, in paper number 27, paper machine head box has been taken into consideration, where head box is the important part of any paper machine, and that is the consistency there is an important variable need to be controlled. And there is whenever we try to model consistency parameter, then there is a lot of delay involved because of the sensor location. So for that, Smith predictor gives an important consideration, where that time compensation can be done. Similarly, in paper number 28, Vikas Joshi, who is my student of MTech, and then where we have used fractional order integrator technique to compensate the delay in the industrial process. SK Sunori et al. In paper number 32 has taken heat exchanger process, which is very prominent in the industries. And this is also having a lot of delay involved because the sensors cannot be applied where the heat is to be measured. So that distance causes some delay in the results, in the responses. And here Ziegler-Nichols integral model control, linear quadratic Gaussian tuning methods are utilized and controllers are designed. And based on that, the compensation techniques are applied and delay compensation is performed. So this is the conclusion where we can see that an exhaustive and detailed literature review of papers for compensation and approximation of inherent delay present in the industrial process is performed in this paper. So a large number of processes are taken into account and different types of compensation techniques are taken into account to exhaustive literature review has been done. And delay is undesirable, we all know, but this is an integral part of any process, and we cannot remove the delay, but we can decrease the unwanted effects of delays. So this is mainly because of the sensor distant location in the form of transportation lag. And from detailed review, it can be concluded that although delay cannot be avoided, but its effect can be minimized on the performance by designing an appropriate suitable time delay compensator. These are the various references which are taken into account in all these literature survey. Thank you.
Okay, so our next presenter is Kumar P, and he's presenting on the paper Smart and Safety Traffic System for the Vehicles on the Road. Dear presenter, you may please start your presentation.
Yes, sir, I'm here. I'm Kumar.
Yes, sir.
So the screen is visible?
Yes, it is.
Yeah. Okay. Good morning to one and all present here. I am Kumar from Rajareshwari Engineering College, Chennai. The title, what we are going to, I am going to present here is Smart and Safety Traffic Systems for the Vehicles on the Road. So it's like in developing countries in like India, population is keep on growing and number of vehicles on the roads are increasing, which may result in heavy traffic jams and road accidents. So which will make the riders in worldwide to accidents and death often because of the negligence in the road safety. So what we plan to resolve this and give a problem for the several problems occurring in traffic sector. And we want to ensure that safety of the person who travels in the road with the help of an IoT based module with ultrasonic sensor and Bluetooth beacon technology and RFID. So in our proposed work, it is a blind spot detection and warning system for the drivers while changing the lane, because they are traveling in a lane. No, when they want to change from one lane to other lane. So drivers get an alert message if any vehicle come closer, and while changing the lane to avoid accidents. And the second thing is nowadays the ambulance services is one of the major services which gets affected by the traffic jams. So what we want to help in helping hand to the ambulance, this paper have come up with the solutions for the automatic signal change from the red to green. Okay. And if any ambulance in the road is halted due to the red signal, then using this system, the traffic signal is changed to green automatically, which helps the ambulance to reach the hospital in time. And third one, what we have incorporated here is drivers who are all violating the traffic rules, such as signal jump, can be detected using the RFID technology. So the same thing I am repeating here in the introduction. So in the whole world, most of the accidents occur during the vehicle lane changes. So accidents also happen in the highway driving while driver have negligence during lane departure, switching of vehicles. So all these things I have already told in the abstract. So in the motivation from that introduction, we have got the motive. What motivation we have is, so vehicles will have a blind spot rear part will there. So vehicles blind spot rear has become a serious problem nowadays. So the blind spot means the blind spot was a viewing angle area of the rear left and right sides of the vehicle that was not covered by the internal and external regular mirrors. So vehicle in the adjacent lanes of the road may fall into these blind spots and the driver may be unable to see these using only the car's mirrors. So they can see only the through the blind spot and through their right side and left side mirrors only. So accidents may occur. So to avoid these accidents, a blind spot detection and warning systems should be developed to alert the drivers before changing the lane. That means if the driver wants to change from one lane to other lane, so we can give a detection and spot detections and warning systems we want to develop. And in the blind spot detection system, we have used the ultrasonic sensors are used to detect the vehicles in the blind spot area. So ultrasonic sensor emits sound waves to detect the obstacles. So how it will work means if a vehicle is detected in the blind spot range, then the microcontroller will send an alert message to the driver. So the alert message is in the mode of vibration. Okay, so what innovations we have taken here is the driver is getting the alert message in the form of vibrations in his this vibration car steering. Okay, so the car steering will vibrate. So the driver could be easily warned that there is a vehicle in the blind spot area. So he will not change from his lane to the other lane. So we have did some of the related work we have did from the these are all the papers we have referred. So from that some existing work, how it was look like is it is lagging in alerting the drivers. It means that they are not efficiently displaying the output to the drivers. Drivers cannot see the output and accidents may happen. So it is there. Now what we are doing is it is there. But the thing is that they are lagging in the alerting the drivers, because how it means the drivers has to keep looking at the LCD display and have frequent distractions from the road. LCD display means it cannot be viewed clearly at the daytime due to the glare. And the processing time also by using some of the RCN algorithm is also high. And LED light is not that much too visible in daylight. So what we have found is the alarm sound cannot heard by the driver while driving in heavy traffic and listening to, because he may be listening to music. So materials like metal and liquid affected the radar sensors. So the other main point what we have got from the existing work is clearing path for emergency vehicles such as ambulance. Suppose if an ambulance if an ambulance is there in that traffic, fire engine, whatever it may be, by changing the traffic signal. Suppose that they are all got into that red signal. So the changing of the traffic signal from red to green in a particular path has various limitations nowadays is there. So they have used the Zigbee system. Zigbee system is also so expensive, and Zigbee is a transmitter will have low transmissions and low network stability. So the existing traffic system is more manual than automatic. And the last thing is RFID, and we have used the two concepts in the traffic clearing for the ambulance. One is by using that one technology, other technology is RFID tag. RFID tag could be easily damaged while affect the signals. So materials like metal and liquid can also can affect the radio signals. So, and one more existing work, what we have found is detecting traffic signals violations as a signal jump. Suppose before the signal change from red to green, the drivers maybe go very fastly. So we want to avoid that too. So that also we will capture by using some of the RFID technology. So these are the existing problems we have formed. So from that existing work, we have proposed our work is first work is accident happen in the blind spot areas while changing lane. We want to keep a blind spot area. We have identified the blind spot area and we will keep the ultrasonic sound waves, the sound materials in their blind spot areas, and we will avoid the light changing when obstacles is near to that ultrasonic wave. And second thing is we will change the red traffic signal blocks the path to emergency vehicles. And third one is traffic rules violation signal jump. So we have did the three parts in this work. The first one is like that in the blind spot detections and warning system. So in that, what we are doing is we have fixed an ultrasonic sensor are used to detect the vehicles in the blind spot area. That means sensors are mounted in the car side bumper and the back side bumper, which emit sound waves to detect the vehicles in the blind spot range. If a vehicle is detected in this range, the microcontroller, this ultrasonic sensor will communicate to the microcontroller. The microcontroller will send an alert message to the driver. How it will be sending? The alert message will be sending in the form of a car steering vibration. So the car steering vibration means that the driver will be able to identify, will be will be given a intimation that some vehicle is coming near to our vehicle. So we should not change from the one lane to other lane. That will be given by a alert message like that to the driver. And the second one is red traffic signal. Suppose if the ambulance is standing in the in the traffic and a signal is in the red platform, in this we can clear that, we can send the ambulance or fire engine vehicles to clear the vehicles. How we did is, we have used that two techniques, that is of microcontroller based BLE Bluetooth low energy beacon technology is used for the traffic lights, because with the Bluetooth low BLE means it's communicating between the two components. The two components will be nowadays, because nowadays all the mobiles are coming with the BLE compatible mobile phones are coming. Okay, so if a vehicle is standing in the ambulance or fire engine is standing in the signal, that the driver should on that BLE compatible mobile. Okay, so it will communicate with the other the signal BLE machine. So automatically the signal will change from red to green. And this is one thing. And the other thing is, if RFID signal also we have used. So in the RFID signal, that is microcontroller based RFID system, is also used to alert the traffic lights upon to arrival for the traffic light junction, which will save their lives at the critical time. So how it is working means, the RFID reader is fitted in the traffic signals post or the lamp post near to the signal, and the RFID tag is fitted in the ambulance windshield. Okay, so in the ambulance also the RFID tag should be fitted, and the RFID reader also should be fitted in the signal post also. So the RFID reader will work only if the signal is red. So if ambulance was stuck in the red signal, the reader will detect the ambulance, and the microcontroller will change the signal from red to green. So this is the second work. And the third proposed work is traffic rules violations. Suppose if anybody is going beyond the traffic rules violations, we can easily identify using an RFID materials, RFID tag. So that is the microcontroller based RFID system is used in automatic directions of people violating the traffic signal. It means the RFID reader is fixed in the traffic signal post or in the lane of before the signal. The RFID tag is attached in the vehicle windshield, or it is inbuilt in the vehicle. So the RFID reader will work only if the signal is red. How it is working? If a vehicle crosses a red signal, the reader attached in the traffic signal post will read the user details stored in the RFID tag and stores it in the database, which is later you can view by the traffic police for maybe for going for a punishment or canceling their license, whatever it may be, they can go for that. So this is our block diagram. So three works have been incorporated. First one is blind spot detection. Ultrasonic sound will be detected and it will given to the direct by the microcontroller. So microcontroller will give the vibrations to the car steering. Second one is ambulance changing from green to red to green. So ambulance will be taken to the beacon transmitter or by a RFID reader. So ambulance, the microcontroller will change the signal from the red to green. And the third work is, if anybody is violating the rule of traffic, by throwing an RFID reader, you can read the details, and the microcontroller will store the details, give the details to store in the database. So this is the overall architecture of overall flow of our work. So this is what I have repeated here in the forthcoming next slide. So this is the blind spot areas. So in the car, we have find the red color point is the blind spot areas. They can fit the ultrasonic sound waves here. So ultrasonic waves will reflect, always keep on reflecting the sound to the obstacles, if any obstacles. If the wave is returned back to that same ultrasonic means, it will communicate to the microcontroller. The microcontroller will give the jerk steering vibration to the car steering. This is the first one. Second one is about the traffic signal changing by using a Bluetooth beacon or by RFID reader. If the signal is detected, means it will change. Otherwise, it will no means it will ambulance will be no ambulance will be there. If ambulance means, Arduino will be changing and the signal change from red signal to the green signal. This is an activity diagram. And traffic violations means through an RFID reader is fixed in the traffic. Same thing. So through an RFID reader, we can able to identify who are all the rule signal violations directions we can able to identify. And for future, you can use it for the any of the punishment or any cancellations of the traffic of license you can use. So the conclusion is, blind spot detections and warning systems in cars gives an alert message to the driver if any vehicle is in a blind spot by producing a vibrations in the car steering. And for ambulance halted in the red traffic signal, this project provides two solutions to automatically change the signal from red to green using RFID sensor and Bluetooth module. And third one is to detect the signal jump cases. A system is developed using RFID sensor. Detected people details is stored in the RFID server, which will be used for the traffic police officer. And the future work is data analysis can also be done in the signal jumping case details to find the count of each individual person violations. and can automatically cancel their driving license if there are any violations count exceeds 3 or count may be fixed by them. So this is our future work. So these are all the references what we have taken for our work. Thank you. Any queries? I am ready to answer.
Hello.
Yes, sir.
Yes, your proposed system is good.
Thank you. Thank you,
I
sir.
would want one question.
Yes, sir.
How much it cost if someone use this in his car or vehicle?
Sorry, sir. How much?
Hello.
Yes, sir. I'm audible, sir. I'm audible.
I ask how much it cost if someone use this model or system in its car or vehicle.
If they want to use this the 3 concepts, it will be very fast to come around within the 1,000 rupees only it will come, sir, because RFID tag is very cheap and ultrasonic is also very cheap. So if we fix all these things, no sir. So this is our proposed model. If you make it as a single component, it will come only of 1,000 rupees only it will come, sir. It will come.
Okay.
Okay. Sir.
Next presenter.
Thank you, sir.
Okay, so our next presenter is Argueta Travania, and paper title Terminal Ontology, Resources of Endogenous Agrosilvopastoral Practices for the Adaptation of Climate Change. She is not here, so we are going to move forward for our next presenter. Muhammad Ali Qazi is presenting on detecting Zeus malware network traffic using the random forest algorithm with both a manual and automated feature selection process.
Hello, can you hear me okay?
Yes, we can.
Brilliant. Hello, hi. Thank you for attending. This paper is based on detecting Zeus banking malware using random forest, and trying to detect the malware using 2 feature selection methods. One manually, and then the other one was by using an automated feature selection process. So the motivation behind this research is that cybercrime is increasing significantly over the years, and there's a little bar chart there which sort of shows you how how the percentage of increase or the number of malware threats that have increased over the years. So there's quite a lot of malware being introduced, and one of those variants, banking malware, is also quite a significant malware which is causing lots of damage and is increasing quite a lot on a yearly basis. So for example, in 2021, banking malware increased by 80% globally, so quite a significant increase. So now there's lots of variants and lots of kinds of banking malware, but the one I focused on was Zeus. And the reason why I focused on the Zeus banking malware is because Zeus is notorious. Lots of researchers have written about the Zeus banking malware and have tried to detect it using various methods. So I've also focused on this malware because year on year, this has been the most detected malware. The other motivation behind researching Zeus is that the source code for Zeus was leaked in 2014, and there's been lots of different variants that have resulted from the Zeus banking malware. There's hundreds of different variants, and there's just 3 examples there: Zbot, Ramnet, Gauzy. So these variants all share the same sort of features as the Zeus banking malware, and they're just as damaging. The other motivation is that the Zeus banking malware can be customized, so developers can create custom modules and add those to the banking malware, and they can do additional damage. For example, they can steal passwords and do various other kind of malicious activities. The Zeus banking malware mainly gets onto people's computers via spam email. So a user gets a spam email and they click on the email and then their computer gets infected. A lot of the times the malware is hidden in documents such as PDF files or Word documents. And when a user opens the file, the computer gets infected. And the other issue is once the computer gets infected, the malware can spread to other computers within the network. It propagates a bit like a worm. And once it infects a computer, it can then begin to steal information such as banking passwords and other, it can do other malicious activities such as take screenshots. And this particular Zeus banking malware focuses on stealing banking information. So it's programmed to sort of understand when a user accesses a banking website, it can then activate and then start doing the, for example, take screenshots, steal passwords, it can intercept communications and so on. The other thing with the Zeus malware is that the Zeus communicates with the malicious actor or the hackers using a command and control channel. So what happens is when a user's computer gets infected, a communication channel is created from the user's computer to the malicious computer where, for example, information can be, once it's stolen, it can be sent from the user's computer to the hacker's computer, and other things can be done. For example, the hacker can download other modules onto the user's computer through the communication channel. And the architecture can either be centralized or peer-to-peer. Centralized is not used that often now because with the centralized one, if the police force or the crime agency manages to find the centralized malicious server, they can just switch that server off, and then the banking malware can't do anything. So nowadays they use what's called a Ptp architecture, which looks a bit like this, where several computers can be infected with what's called a bot. So there's 5 PCs there, for example, and there's all those machines can effectively be a command and control server. So basically, as the information is stolen, it can be routed through the network through the various bots to the bot master, and that way these bots are harder to take down. So this research focuses on trying to detect the communication that occurs between the various bots and the bot master, and there's lots of ways that can be done. And some researchers have used signature-based methods. Some have used but there's quite a lot of different ways of doing it. But there's 2 methods mentioned there. But the focus of this research was using machine learning to detect malware. There's many papers on that. I've selected a few here, which are quite famous out there. So, for example, Bot Hunter was developed to detect the CNC channel, and there's different research. For example, there's Conifer, RCC, which are all geared towards detecting malware. This research looked at detecting the malware using random forest, and the idea was to try and detect malicious communication and also non-malicious communication. The first task was to obtain the Zeus samples. These were obtained from various antivirus and anti-malware sites. And then once those were collected, the features were extracted from those samples. So basically each sample has what's called flows, and those flows are the communications. So those flows were extracted, and basically from those 44 features were extracted from the flows. Once those flows were extracted, I used random forest then. So I used then a random forest to train and test the to detect the malware. And what I found is there's some information about the samples here. I used, in this particular research, I used 3 samples. One had 1024 flaws. The other 2 flaws, the other 2 samples, one of them had 35,000 roughly flaws, and the other had about 60,000 flaws. And what I found is that when I experimented with the features, using the manual method, these particular features were the ones that produced the best results. So these features were the ones I used for the manual feature selection. And when I use this particular selection, the training results, you can see in the table there, were quite good. But more importantly, the actual prediction results were also quite good. And in the case of the first data set, out of 222 Zeus samples of flaws,
Sorry to
206
interrupt you, but
Yep.
you have last 2 minutes.
No problem. And then, so there's the results there. And then you can see that from the automated algorithm, I used ANOVA. You can see the training accuracy there. And also you can see that the prediction results were also quite good here. So to summarize the paper, random forest is able to detect these communication flaws. And hopefully in the future work is to try and increase the samples and try and see if this methodology can detect other variants of Zeus and other banking malware as well. Are there any questions?
Hello.
Hi.
Yes, your presentation is good, and online transaction is the main challenge for the online banking, etc. The only way is we should be very careful in online transactions. As we know that we can't avoid online transaction, etc. So the only way is should be careful.
Yes. So in this research, I also looked at to make sure that we predict the non-malicious traffic as well. So that traffic that's not malicious, for example, when a user is doing normal banking or when a user is doing, for example, other, browsing activity. So this algorithm also tries to predict non-malicious traffic as well.
Yes.
And the results there, as you can see, non-benign traffic, it's not as accurate, but still quite good. So for example, in this the bottom one, CTU data set 2, we can see that only 26 so you can see the results there are quite good. So for Zeus and for non-malicious, benign meaning non-malicious traffic.
Yes.
Yeah, but good. That's a good point. That yeah.
Thanks. Next presenter.
Yes, moving forward for our next presenter is Pallavi Tiwari, and she's presenting on Twitter sentiment analysis using machine learning and deep learning.
Yes, sir. Is my screen visible?
Yes, it is.
Okay, thank you. Good afternoon, everyone. I'm Pallavi Tiwari, currently pursuing my master's from Graphic Era D2 University. I'm here to present my research paper, Twitter Sentiment Analysis using machine learning and deep learning. I would like to thank the organizer and all the sponsors to provide me with an opportunity to present my paper. This presentation is structured as follows, where we're going to understand what sentiment analysis is and why we need sentiment analysis, why Twitter data for analysis, what is the problem statement and challenges while performing data analysis, the workflow, or the steps involved in Twitter sentiment analysis, whose first step is collecting the data. that means data sets. Second is data pre-processing. And the last step is the different approaches used for sentiment data analysis, results and comparison, conclusion and future scope. And lastly, references. What is sentiment analysis? Sentiment analysis is the process of computationally identifying and categorizing opinion expressed in a piece of text, spatially, in order to determine whether the writer's attitude towards a particular topic, product is positive, negative, or neutral. Why is sentiment analysis important? A simple answer to that question will be opinion of the mass is important. Before investing into a company, one can leverage the sentiment of the people for the company to find out where it stands. A company might want to find out the review of its product because knowing customers' opinion about your product and service enable organization to discover key areas that requires improvement in order to meet the customer need. Sentiment analysis has been used by political candidates and administration to monitor overall opinions and policy changes and campaign announcement, enabling them to fine-tune their approach and messaging to better relate to voters and constituents. It can help to predict which candidate can win an election by people's positive and negative opinion about them. Sentiments may at times hint at future price action. Why Twitter data? Social media platforms such as Twitter, Facebook, Instagram, YouTube, etc., have been so popular for nowadays. They allow people to communicate, create networks, and share thoughts easily and promptly. Twitter is one of the fastest growing social media sites and become very popular microblogging site over the last few years as people openly express their opinion. The problem statement is to perform sentiment analysis using machine learning classifier and data learning, deep learning model, compare the accuracy and F1 score. The challenges of the Twitter sentiment analysis are tweets are highly unstructured and also non-grammatical. Out of vocabulary words are used, lexical variations are there, extensive uses of acronym like ASAP, LOL, AFAIK is used. The workflow: collecting the Twitter data, cleaning the data, modeling the data, where two approaches are being used, machine learning and deep learning. Next is the performance measure. Here, in this case, accuracy and F1 score of the classifier. And lastly, the analysis and comparison is done. Twitter data set. Data set is one of the pillar of deep learning and machine learning. For training, we need a large data set, and to perform the experiment, we'll need a large number of open source data set. We can obtain data set from Twitter API, Kik, and sometimes from GitHub. TweePy is the Python library that is used to access Twitter API. Data pre-processing. The pre-processing of the step is crucial task. So therefore, the steps that are being used while performing this experiment are tokenization, removing unwanted patterns from data, removal of stop words, cementing, lemmatizing, creating bag of words, splitting the data, standardization. The figure shown are the outputs that has been while performing the experiment. Next is sentiment analysis. In the survey, 3 machine learning algorithm is used as shown, which according to the papers I've read for literature review generate better accuracy, and one deep learning model, STM, long short-term memory, is used for sentiment analysis. In upcoming slide, we'll see the results. In logistic regression, as you can see, is the confusion metrics of the confusion logistic regression. Accuracy and F1 score is 0.94 and F1 score is 0.59 for logistic regression. Same we can see for the decision tree. Accuracy is 0.93, F1 score is 0.53. Random forest, accuracy is 0.95, 0.60. LSTM, we have the accuracy of 0.94 and F1 score of 0.63. The table shown is the results table having accuracy and F1 score of each algorithm used in this experiment. For this table, it is evident that random forest has the highest accuracy and the F1 score. So the conclusion is that in this proposed paper, 3 machine learning and 1 deep learning algorithm is used for classifying the Twitter data into 2 classes, being positive and negative, which by literature review concluded to be the best one and produced the best accuracy when compared with others machine learning matching algorithm. And now, after this experiment, it had been concluded that random forest produces the best accuracy 0.95. The future scope of this world includes multi-class classification of Twitter data into 3 or 5 different classes and using different models to compare which performs better when it comes to multi-classifying the sentiments of Twitter data. We can use the combination of models for the better performance. These are the differences used. Thank you. Any questions?
No. Next presenter.
Okay,
Thank you.
so our next presenter is Yashoda Barve, and she's presenting on an incremental approach to classify healthcare URLs using a novel web document classification model.
Yes, sir, I'm sharing the screen.
Yes, yes,
Is the screen visible?
yes, it is.
Good afternoon to all. I'm Yashoda Barve, Assistant Professor, SCMIT Pune, India. I'm here to present on a topic an incremental approach to classify healthcare URLs using a novel web document classification model. Here are my co-authors, Dr. Jatinder Kumar Saini, Professor Director, SICSR Pune, Dr. Ketan Kotecha, Professor Director, Symbiosis Center for Applied Artificial Intelligence, Hema Gaikwad, Assistant Professor, SICSR Pune. This is the agenda for today's presentation: introduction, literature survey, research gaps, contributions, methodology, experimental results, conclusion, limitations, and future enhancements. We'll begin with the introduction. So in the real world, information diffusion takes place through the word of mouth. However, in the digital world, information dissemination occurs through word of media. Internet has become an information hub for users due to its low cost, easy access, and expediency. Especially in the healthcare, information is readily available to the users in immense size. People surf internet for information on sickness, symptoms, and hunt for preliminary treatments. In a survey, it was observed that 65% of the users use the internet to explore health-related subjects. Thus, maximum users prefer internet information access. However, there are certain challenges. There are millions of URLs available on the web related to healthcare, and they might be duplicated and irrelevant, which creates information overload to the users. Users have to put in a lot of efforts to search relevant web pages. Also, researchers and scientists working related to healthcare face challenges in getting relevant information. Thus, it is a challenging task to extract and organize web information relevant and contain domain and until to a specific domain. Also, data in URLs may change over the period of time, and these changes have to be recorded to provide updated information. So certainly this is the problem of information extraction and text classification. Researchers so far have developed models with the help of machine learning classifiers, clustering, ensemble learning, incremental learning approaches to overcome these problems. So in the proposed methodology, we are using sentiment analysis, document similarity, and incremental learning approach to classify URLs into relevant and irrelevant, remove duplicates, update newly arriving data, and detect changes in the data. Next is the literature survey. Literature survey is divided into 3 parts for this particular model. First is information retrieval. Information retrieval has 3 major components: fetching of URLs, that is domain specific URLs, pre-processing of the URLs or the contents, and then building a vector space model. So when we fetch the URLs specific to a certain domain, we need to get the domain specific keywords, match the keywords, retrieve URL list, remove duplicate URLs, and then we need to rank those URLs. Pre-processing involves basically the cleaning steps of removing the punctuations, numbers, converting to lowercase, removal of the stop words, stemming, lemmatization. And a vector space model converts actually the textual data into the numeric data using TF-IDF, and backward words. So the areas marked with red boundaries are part of our proposed model WDCM. After we get these URLs, we're supposed to filter these URLs. For that, we require to extract some features. There are different types of features which can be extracted. First is linguistic features, topical features, sentimental features, and document similarity features. Linguistic features talk about the number of words, sentences, characters, or grammatical features in the text. Topical features focus on the topics related to a particular domain. Sentimental features help us to determine the feelings of the people in terms of positive, negative, neutral words. Emotions can be captured. Document similarity features are basically used to find the similarity, and they are mainly focusing on the classification task. Apart from that, to detect newly arriving data and changing data, there are different techniques in the literature which are used. First one is incremental learning, second ensemble learning, third reinforcement learning, fourth deep learning or artificial neural network. The incremental learning basically employs a method of updating a single model by incorporating newly arriving data. That means it adapts to the new knowledge by keeping the previous data. It never discards the history. It's a more efficient algorithm compared to others, and it is more suitable for smooth concept drift. When it comes to ensemble learning, the data is divided into different chunks, and each data chunk is trained on a different classifier. And this type of model is more suitable for sudden concept drifts. Reinforcement learning contains one agent, and the agent takes the decision based on the previous data, and it either gets the reward or the penalty. So based on that, it takes the decision. Such type of model requires huge amount of data, and they are more suitable for robotic type of applications. For deep learning and artificial neural network, the major problem is catastrophic forgetting, meaning the model forgets the previously learned knowledge as the new data arrives. This requires a lot of memory space and training time. So considering all this, we prefer using incremental learning because we wanted to build a single model and we wanted to keep the previous knowledge also. There are different techniques of incremental learning which are used. First is query or context refinement. In this, the keywords, domain keywords are updated as the new URLs pop in. Second technique is based on the newly arriving topics, the clusters are updated. Third is identification of new classes, identification of new features, updating existing features, and increasing the feature space. This is like when new URL is fetched, new terms would get added, and those terms would be appended to the feature list. Next is research gaps. So from among this, we have understood that, however, there are high-level semantics in the text, meaning domain-specific keyword-based retrieval models have been built. There are high-level semantics in the text that cannot be captured with only domain-specific keywords, because word involves synonyms and antonyms also. Therefore, there is a pressing need to identify semantics in the text by considering the synonyms and antonyms of the words. The recent techniques of incremental learning approaches for text classification update existing features, and they do not deal with newly arriving terms or phrases. Therefore, there is a need to build a model to adapt to the newly arriving terms and append them to the feature space. So in our research, we have tried to overcome these research gaps by adding synonyms and antonyms of the terms in terms of semantics. Model is able to classify URLs into relevant, irrelevant, related to healthcare domain, and remove duplicates as well. Model has adapted to newly arriving features of the terms, and the model is able to detect changes in the URLs and provide up-to-date records of data. This is the methodology. So the user enters the search keywords related to domain specific, and the list of URLs pop in. The model checks if there is an existing URL. If it is an existing URL, model will test and find out if there are any changes in terms of sentiments and similarity measures. Next is, if it is a new URL, then all the sentimental features are extracted and they are matched with the sentimental bag of words. This sentimental bag of words is prepared manually by us and related to healthcare domain, and those words are matched with these particular sentimental words or the terms arriving newly in the data. After that, we have also prepared a seed URL repository. This contains relevant and irrelevant URLs set of 100 URLs, and based on that, the distance measures or the similarity measures are applied to compute the similarity between the newly arriving URL and the existing URLs. And then the classification of URLs is done. Again, it enters and fetches the new data, and that details are stored in the URL repository. These are the experimental results. So for the data set, we have used 2000 URLs, out of which 1500 were considered as relevant, 500 were irrelevant URLs. For seed URLs, we have taken 100 URLs, out of which 60 were relevant and 40 were irrelevant. If you look at the performance metrics, this is feature-based. That means similarity measures, sentimental features are used, and different classifiers are applied. That is logistic regression classifier and SVM classifier. This is the accuracy of the model based on the distance measures with machine learning classifiers. This is the highest accuracy which we have achieved for cosine similarity. This is Euclidean distance measure and this is Jaccard distance measure. So cosine similarity has outperformed others when it comes to feature-based approach. Same as these are the results for precision, recall, and F1 score. There, I guess all the models have performed well for precision, and highest is cosine in Jaccard for recall, and for F1 score it is 96.36 for CS. Then we computed harvest ratio, which is the number of relevant URLs divided by the total number of URLs fetched. So this is the harvest ratio of URLs with respect to distance measure for logistic regression classifier. So we can see that Jaccard distance have outperformed others and fetched the more relevant URLs. Harvest ratio.
Sorry to interrupt you, but you
Yeah.
have last 1 minute.
Okay. So these are the harvest ratios for that. This is incremental learning. We scrap the same URLs again at time T2 and T3. And this is the state, like 33 URLs got changed at time 3 and 70 URLs got changed at time T2. This is the confusion matrix. This is algorithmic. We have used this as a classifier also. These are the threshold values used at time T1, T2, T3. .com type of URLs were the highest one compared to others. So in conclusion, URLs try to keep changing and these changes have to be recorded. In our model, cosine similarity outperformed others. Then in case of feature-based approach, in algorithmic approach, Euclidean distance outperformed others. So limitations is we are not doing multi-class classification here, and the model is not suitable if somebody wants to only fetch relevant URLs. In future, we want to build our own classifier without our distance measure, and we want to build a model that will collect only relevant web page URLs. These are the references used.
Sir, is there any question for the presenter?
No, next.
Okay. So moving forward for our next presenter is Gunjan Singh, and her paper title is a text classification optimization framework for prodigious datasets.
Yeah, thank you so much. I'll just share the screen. I hope my screen is visible.
Yes, it is.
Yeah, thank you so much. Very good afternoon to all the panel members. I am Gunjan Singh and I'm a research scholar. I'm doing it under the guidance of Dr. Arpita Narpal, who is an associate professor. My topic is a text classification optimization framework for prodigious data sets. The contents include the introduction, hierarchical attention network, Tunicate swarm optimization, improved cosine algorithm, research methodology, research and analysis, which contains the data set description, then the performance parameters, then comparative analysis, and then the conclusion. So I'll just start with the text classification, which is also known as text tagging or text categorization. It is a process of categorizing text into organized groups. Few sources of data text, these include web data, emails, chat, social medias, etc. And it is an extremely rich source of information. However, extracting insights from text can be challenging and time consuming due to its unstructured nature. So these text documents, they usually contain high dimensional, irrelevant and noisy terms, which leads to poor performance of the classifiers. And hence these should be further processed before the text classification in order to reduce the dimensions and remove irrelevant and noisy terms. So this text classification aims to assign labels or tags to the textual units such as sentences, queries, paragraphs, and documents, which can be performed either through manual annotation or by automatic labeling. However, with the growing scale of text data in industrial application, automatic text classification is becoming increasingly important. Now coming to the feature selection. Now feature is basically the indivisible unit of the text corpus. And feature selection becomes very important in text classification pre-processing, because through the feature selection process, it helps in reducing the high dimensionality of feature space. And it is further used to reduce the error rate of the classifier and reduce the computation time. Now, it also this framework, it also contains the hierarchical attention network, which is basically used for the purpose of text classification. Now, the intent of using this hierarchical attention network is basically to capture two fundamental experiences about document structure. First one being any of the document, it contains the hierarchical structure. As the word forms the sentences, and sentences forms the document, and each of these word and sentences, they are distinctively informative. So in order to find out their importance, it becomes very important that we find out how much they are context dependent and how much they are relevant in, if we talk about the document. Then I made use of tunicate swarm algorithm. Now this tunicate swarm optimization algorithm, it is a bio-inspired algorithm, and it considers the swarm behavior as well as the jet propulsion of tunicates, which is done at the hour of scrounging and the route process. So these are tunicates are the standard bio radiant that creates a light, and it is with this light can very well be seen from a very long distance. And these tunicates, they can survive for a longer time in the ocean. And the tunicate is a creature that move around the sea with an impetus interaction that is very much like a liquid. And the multitude conduct and the stream impetus of tunicate swarm algorithm assists with expanding the assembly base of these enhanced and subsequently empowered to create global best arrangement by disposing of the nearby optima. So what I did was I combined this tunicate swarm algorithm along with the hierarchical attention network for the text classification, and then I compared it with already existing improved sine cosine algorithm. So the improved sine cosine algorithm was introduced by Belazong and Attard, and it was used for selecting the features, and it discovered new region of search space and focus on best solution for generating the optimal solution. It considered two solutions, namely the location of best solution and the random location from search space, and it allowed to eliminate premature convergence and increase the performance. And it is efficient to resolve the feature selection problems, but it failed to apply this method to other complicated problems. So now comes the research methodology. Here in the input data, we give an input data, data text as an input. Then the pre-processing step takes place, wherein the stemming and the stop word remover takes place. So after that, the feature extraction takes place, wherein the which is done using the WordNet features and co-occurrence based feature TF IDF features. Once we extract all these features, then the feature selection takes place, which is done using the TSA tunicate swarm algorithm. Then the text classification takes place. Now, for the purpose of this text classification, we're using hierarchical attention network. So this hierarchical attention network makes use of two attention layers, which basically comprises of the word encoder, word attention, then the sentence encoder, and the sentence attention. So this hierarchical attention network is trained by tunicate swarm algorithm, and then finally, as a result, we get the classified text. So this is what I have already explained to you. So now coming to the research analysis part, I would like to explain about the data set description. So for this purpose, I have considered three data sets. One is the Reuters data set, another one is the 20 news group data set. The third one is the real-time data set. It is basically the self-created data set. Now these two data sets, Reuters and 20 news group data set, these are the standard data sets. So Reuters data set contains approximately like 21,578 instances. And 20 news group data set, it contains somewhere around 19,000 instances. And the real-time data sets, which I have created it on my own, it contains approximately 5,000 documents, and all these documents, they comprise of the abstracts taken from the various reputed journals, and it includes 20 topics which are selected, and for each topic 250 papers are collected from Springer and Science Direct web sources. So 5 performance parameters have been considered here, namely accuracy, TPR, true positive rate, TNR, true negative rate, FNR, false negative rate, and the precision. So the comparative analysis has been made here. The comparison has been made for TSA-HAN with ISCA, which is an existing technique, TSA-HAN, which I have been working on. So the training data set has been taken to be 60%, 70%, 80%, and 90%. And it has been done across all 5 parameters, TPR, TNR, accuracy, precision, and FNR. So this has been done for this analysis has been done with the Reuters data set. And it shows for ISA of TPR for 60% training data, it is 0.700. For TSA-HAN, it is 0.799. If we talk about TNR along the same training data percentage, it is 0.72. And for TSA-HAN, it is 0.81. If we have a look at the entire table, we can see this TSA-HAN, it outperforms ISCA in terms of TPR, in terms of TNR, in terms of accuracy, precision, and FNR. Now coming to the analysis with 20 newsgroup data set. So with 20 newsgroup data sets, again, this 5 parameters have been considered with the training data value at 60%, 70%, and 90%. And here also, if we have a look, it shows that if we talk about the maximum value, so that shows to be 90% for TPR. ISCA value shows to be 0.82. And TSA-HAN is 0.88, TNR is 0.82, and TSA-HAN is 0.91. Accuracy is 0.91 for TSA-HAN, and ISCA it is 0.812. For precision, it is 0.93, and ISCA is 0.768. FNR is 0.115, and for ISCA it is 0.178. Now coming to the analysis with the real-time data, which is the self-created data set for 5,000 documents that I have created. So for that, if you talk about the 90% training data, it comes out to be, the accuracy comes out to be 0.92 for TSA-HAN, and for ISCA, it comes out to be 0.823. For precision, it is 0.94, and for ISCA, it comes out to be 0.776. And FNR is as low as 0.11 for TSA-HAN and 0.216 for ISCA. So it can be concluded that TSA-HAN works marginally better as compared with an existing technique, improved sine-cosine algorithm, which is ISCA, in terms of the 5 popular parameters, namely accuracy, precision, TPR, TNR, and FNR, which provides 0.874, 0.915, 0.865, 0.901, and 0.137 respectively with Reuters dataset, and 0.913, 0.935, 0.884, 0.913, and 0.115 respectively for 20 newsgroup dataset, and 0.921, 0.9471, 0.889, 0.899, and 0.111 respectively for real-time data sets. Further, it has been noticed that with the increase in the number of iterations and the percentage of training data sets, it shows the better results. So hence, it can be in future it can be combined with different algorithms to obtain better results. And also, there are certain other techniques also which can be worked upon in order to further improve the results. So this is the reference part. The references have been taken from all these sources. So thank you so much. Am I audible?
Yes, you are.
Yeah, okay. Thank you so much.
So, any question?
Next.
Okay. So next presenter is Parmeshwar Birajdar, and the paper title is Catering Worldwide Network-Based Iris Classification and Approach to Deprecation. The presenter, you please start it.
Am I audible?
Yes.
1 minute. I am sharing the screen. My screen is visible?
Yes, it is.
1 minute. Okay. My topic is scattering wavelet network-based iris classification, and it is an approach towards the deduplication which can be used for Aadhaar applications. Basically, in Aadhaar, we are enrolled three main biometrics, that is face, fingerprint, and iris. And this is my part of my PhD extension. I have done from IIT Bombay this work in the field of biometrics, and this is extension of that work we have started here. So in Aadhaar, actually, the iris biometrics are captured using the near infrared wavelength, using your specially designed cameras for iris capture. But nowadays, we can use visible length iris capture using the available smartphone cameras, and that we would like to see how it can be used to avoid the deduplication. Means what? There should not be a repetition in the database of Aadhaar. So that part actually we require, and if we can do that, we have to search every time. We have to search the entire database before entering the new iris or new identity in the database, because we have to compare each and every biometric. Uh, that's why here, if we have some classification, and based on that classification, if you can do pre-indexing, so that your search time towards the large database, more than 100 crore already enrolled. So in that, the time can be saved. So my presentation outline over here is basically what are the iris classes. Okay, and the next the approach we are used in this classification is the scattering wavelet network that I will explain later, and the classification, the structures, or what kind of features that propose catnet based iris classification, I will explain. Then iris pre-processing is needed for region of interest extraction stages. Also, the database is used for iris classification, how the feature vector is constructed and classified, and few experimental results. I have shown few experimental results in this presentation, and maximum results are there in the paper. Okay. So basically here, there are three types of iris classes are defined now. The first one is the stream, flower, and the third one is the jewel. So this is nothing but based on the iris fiber structure. Okay. It depends upon the orientation or structure of these fibers present in the iris. So based on that one, three classes are available right now. One is stream, and flower and jewel, and these are the examples from these two different databases. One database is from UPOL database, and other is from the Warsaw Biobase Part 4 IRIS database. So these standard databases we have used, which are captured using smartphones. So that database we used, and these are the three classes over here. And our intention is to classify these classes based on the images available to you. And this is a scattering wavelet network. Basically, it is a CNN kind of thing, convolutional neural network type. But in CNN, we don't know which kind of filters are there, how much depth of the network is there. All these hyperparameters are not decided it depends upon training and testing and all these things. So that is not here in this case. This scattering wavelet network is basically inspired from Stephen Mallat, the pioneer in the field of wavelet. He has developed this network, and we have utilized this network for our classification of iris. Let me explain in this diagram. This is f of xy is an image, a two-dimensional image, and this phi function over is a scaling function in the wavelet, or it is also called as averaging function. So, and this psi here is the wavelet, psi lambda 1, psi lambda 2, psi lambda 3, all are the wavelet functions. Now, basically in CNN, what we are doing, we are averaging every time. We are convolving with filters, and here filters are wavelet filters, that is psi filters. And in this application, we have used the Gabor wavelet over here, and and many times we are doing averaging, similar averaging in CNN. Here we are using the scaling function pi, and we always introduce non-linearities in CNN, and here we have used a modulus operator for non-linearity. So here modulus operator plays an non-linearity introduced to extract the features. The wavelets are psi and is pi. So these black dots are the wavelet convolutions, and where are the white dots are the averaging output. So averaging and high pass, low pass filtering, high pass filtering, low pass filtering, high pass filtering. So we can go down structurally every time we are passing this low pass structure to the next layer. So here we have used 3 layers: layer number 1, layer number 0, where we have captured only the low pass information by averaging out, and M1 and M2 like that. So this is a structural thing of this scattering wavelet network, and we are used to extract the features. And specifically, we are used the 3 levels of wavelets, j is equal to 3, okay, and 3 layers, and orientations we have used 24 orientations, okay, lambda, that is lambda 1 to lambda 24 orientation Weber filters we have used here. So this is our block diagram of iris classification. First stage is very important step is we have to segment it out, the iris part from the eye image, then the iris normalization, we have to convert the circular part of iris into the rubber sheet, then the iris enhancement weekly, sometimes during capture, due to the illumination effects, we have to enhance the things. We need some enhancement stages. We have done that here. Then we have divided the entire rubber sheet into square parts, square blocks, that is called square destinations. Then finally, all these blockwise operations we have applied on this scattering wavelet network. The input for this one, each block of that one is passed. And finally, we have taken the mean of the wavelet transforms of these each stages, mean coefficients, and finally we have used 2 classifiers. Specifically, we are using PCA-affine, and also we have compared with the SVM classification. So these are the iris pre-processing steps and some results: original image and segmented image. We have used some standard algorithms of segmentations. Our main work is to extract the features and the classification. And then this is rubber sheet is the normalized structure. Now you can see the enhanced version of that one is also, we have used some standard enhancement techniques over here. Then we have divided the entire rubber sheet into 16 blocks. Entire rubber sheet to 60 blocks, and each block is passed to the scattering wavelet network. And in this experimentation, we have used 2 databases. One is called UPOL and other is called the Warsaw Bio-based smartphone iris databases. Now here, the predefined classification is already available, because at least we know what is the basic classification. So in this, this classification is already available in the literature for stream, flower, and jewel. But this size of these images are very less number are there. If you see here, 192 plus 200, around 300 images are available only for UPOL database. So such database will not be sufficient for classification application. That's why we have used another database, and we have done a subjective analysis on that, and we have classified this second database, the Warsaw Bio-based smartphone database, into these 3 classes. So we found there are 760 images from stream class, then flower 400 and 180 jewel. So we have given the numbers, and this database will be made available to the researchers later on once our paper will be published. Now these are the feature extraction steps. So we have divided the entire rubber sheet, the horizontal part, destination part, into 16 blocks. The rubber sheet sizes for 2 different databases we have differently used. One size is 180 by 360, and the other for 192 by 1536 for UPOL and Bio-based database respectively. And as shown in the block diagram of the scattering wavelet network, we have used 3 layers of scattering wavelet network, because that 3 layers are sufficient to extract the features. And after 3 layers, we have concatenated each block, feature of each block, and mean of each block is calculated. Mean feature is used, and this is our feature vector. Okay, and for classification, we have used nonlinear classified SVM, as well as the linear version of the another is PCA-affine classified, and we have made a comparative analysis over here. Now here we can see two sets of results. One is on Upol database and other is on this Warsaw database. And mainly we have done experimentation based on complete iris, lower iris, and side iris. What we mean is, let me show you here in this diagram. Okay, the left portion is sufficient, only the right portion is sufficient, or entire iris portion is required. Sometimes occlusions will be there. Sometimes the entire image will not be available. Only due to the occlusions of eye, or due to camera focus, or some this noises, you can say. If partial information is available, in that case, then can we classify, or whether that information is sufficient or not? That we have tested over here. We have only used lower iris information, and side iris information, and comparatively complete iris information. So in this also we have got same result for side information also. It is 81.78 for PCA. Of course, in the entire experimentation, we have found that PCA is performing better than SPM on the scattering features. That is the property of the scattering features, because we extracted the linear kind of features over in the terms of wavelets. So that is there. So I'm focusing only the PCA part over 81, 84, and if you see here, 81% for complete. Means we can classify the images using partial information also. Means we can take in consideration the occlusions in the iris images. So that is there.
Sorry to interrupt you, sir, but we have last 1 minute.
Yes. I am going quickly. Okay. And also we have compared, and there is no much work is available in the literature. Only few work is there, and whatever the work is available there, we have compared with that one, and we have obtained the similar accuracy of 100% with the previous literature. That is to reference number 7 and 8, and we have now put our result using SCATNet, that is using the Warsaw database, complete iris and full iris at 99.2 and 100. So this will be for the next researchers can compare with the database, and database will be made available. So this is final conclusion. In this research work, we have used a novel scattering wavelet network based approach for fixed iris classification based on the iris fiber structure. We have also studied the impact of partial iris information, lower iris, side iris, on the classification performance. It is observed that partial iris information is sufficient for classification on the iris-based fibers, and PCI affine classifier works well with the scattering wavelet features. And finally, we can say this type of classifications in the future version of the Aadhaar, if we are using the smartphones and we are enrolling the new images, so can we use this type of classification for iris indexing? Of course, we can use this type of classification. This is from my side. Thank you very much. Any question?
So is there any question?
Hello.
Hello.
Yes, sir.
Yes. Which platform you use for this classification?
Which platform? MATLAB, sir. In MATLAB, we have done this.
Okay. MATLAB. Next.
So next, our presenter is Sarfuddin Wasim Mohammed, and is presenting on smart water resource management by analyzing soil structure and moisture using deep learning.
A very good afternoon to one and all. Yeah, myself Mohammad Sharfuddin Wasim, sir. So let me share the content. Yeah, is my slide is visible, sir?
Yes, it is.
Yeah. So the topic is smart water resource management by analyzing the soil structure and moisture using deep learning. So this is the research that has been conducted with the DST funded project under the scheme of DST seed. So in this model, basically most of the smart resource management do work on the soil moisture sensors. So here we are trying to introduce a concept of image processing along with the soil moisture analysis. So basically, most of the systems do need to have an high computing devices. So the main motto of our research was that how we can able to uh, enable the cloud and the fog computing to the edge computing. So we are just trying to transfer the computation towards the low computing devices. So in this aspect, we have made a research on collecting the images and trying to classify the images based upon the soil structure and the moisture ratio. We are going to control the water resources in an agriculture field. So in this, we have first gone with an collection of data that has been we have we have taken the data from the Kaggle data source as well as the customized data source. So now we made into 4 different classification that particular soil structure, and we classify that, and accordingly we have controlled the devices of the agriculture field. So today's my content is the objective, the literature survey, architecture of the proposed model, methodology, the discussion on the results, and the conclusion. So now the objective is the smart resource, the resources which are there, we need to control that resources, and we need to make the water management in such a way that the crops, depending upon the crop and depending upon the soil structure, we can control the water management. So this is a literature survey, and in all the literature surveys, either they have gone with moisture sensors, or they have gone with other type of sensors from which the data has collected. So our unique thing is that we are making a combination of image processing along with the moisture sensor. So here, this is a proposed architecture of a model, which actually the flow is something like this. So we acquired the image from the real-time field, and that is uploaded to a cloud, and this is a continuous process in a due time. Okay, from where the recognition task, the left hand side here, the recognition task, which will perform on a local training machine with a VGG19 as a backend model. So this VGG19 will help my model to classify and to make the features. So we are trying to learn the model, that whether the image belongs to which type is. So we are trying to learn a new feature from the provided image, and we are going to make a deep learning framework with the help of which we can able to train the data set. So once I get a trained model from which I can able to classify like which type of soil is, and later I'll try to convert that image into an TF-like model with the help of which I can able to transfer this pre-trained model into my on-premises device. So this is a continuous process of recognition task, that whenever I got some new changes into my field, whether it might be a crop changes or it might be the soil changes. Definitely the soil is not going to change in a particular area, but in the due time, if I change the crop, then accordingly the need of that particular crop, the water management for the crop is differ when compared with the water management with some other crop. So hence basically we are trying to go with the image acquisition for every crop, and for every time, every season, we are going to make that inference model, and that inference model we are going to be host on an on-premises devices which is now capable, like Raspberry Pi or some other controllers of STM, we can make use of to find out, to make a decision. And this decision making process will try to take a picture again, and it take the sensor values, and which have both the image as well as the sensor, moisture sensor values, and accordingly we make a decision whether how much time, amount of time my water pump has to be enabled, and at what level I can stop the water pump is. So basically this model is always a self-learning model. So hence we develop this model with the help of a VGG19 as a backend, which is the architecture of VGG19 to classify the image. So now the methodology is, as I told just now, that in the traditional water planting, we consider the water, and if the water is sufficient to the plant, then we'll stop the water resources. So here we are taking the need of the crop, and accordingly we are making a smart irrigation approach. So now these are all the devices that what we use to capture, and we are just tested the model on a small scale of region. Hence efficient for us. And with the Raspberry Pi, we have make an on-premises device with the help of which I can able to control the devices. Okay, so these are all the sensors. This is a moisture sensor. Basically, we use to go with taking the values of moisture from the soil, and this is a step-by-step process, like initializing the sensor and collecting the data from the sensor and storing those information into the Raspberry Pi basically. And then we are trying to compare the data with the pre-trained model, which I explained just now, and we are trying to control the hardware devices. And then later on, for the future aspect, we can able to tell the farmer, like in the so and so field, suppose he's on wheat or rice or some other crop like paddy, then we can able to justify like what exactly. So we can make the statistics of how much water has been utilized and what is the changes. So it also depends on the season. So hence there is season, like whether the soil is dry and so on, we can able to justify. So these are the outcomes that the revenue of the farmer can be increased with a precision agriculture. So this is the results. Like we have used a kit which is shown here in the picture. Like we have make use of all the sensors, and we made a small water pump to pump the water. So basically this was just a model that we have done, we have tested in our lab, and we are in the result, we are in the process of implementing it in a large scale scenario. So now this is the conclusion, like we can able to make a low cost devices that can able to control the smart water resources onto the on premises with the help of advanced pre-trained models, which can be accurate to make a precision agriculture. So these are all the references that I made to write up this paper and this research. Okay, thank you, and thank you one and all. If you have any queries, then you can just ask me.
Hello.
Yes, sir.
Yeah, no query. Next.
Thank you so much.
Our next presenter is I will be Meenakshi, and her paper title is Analysis of Various Toxic Gas Levels using IGMLIT for Air Quality Monitoring and Forecasting. Since it's not here, I sincerely thank our authors for the excellent presentation in this session and all our participants for being a part of this international conference. I hope this session was informative enough. And there's a one note that all the presenters will be getting the digital certificates through email within 2 working days. All the papers have already forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team ICTIS 2022. I also thank our session chair, Dr. Bharat Singh Deora, for chairing the session. And there's one token of appreciation from the team ICTIS 2022 and the Global Knowledge Research Foundation. Thank you, sir, for your valuable presence. And end of the session, dear all, I'll kindly request you all to turn on the camera for a quick snapshot of the virtual conference.
Hello.
Yes, sir.
Yes, I want to say a few words.
Yes, sir.
Yes. It's my pleasure to be part of this session today, and I would like to thank Mr. Amit Joshi, Director, Global Research Foundation India, and also thankful to Mihir Chauhan sir and Amit Barot sir. The objective of this international conference is to provide opportunities for the researchers, academicians, industry persons, and students to interact and exchange idea, experience, and expertise. I always encourage my scholars to participate in such conferences which provide common platform for academicians, researchers, scientists, engineers, and students to share their views and achievements. The conference and sessions are well organized, which is specialty of all conferences organized by Dr. Amit Joshi sir. I will congratulate all the participants. I have planned to join the conference in physical mode, but due to some reasons, I will be not able to join the conference in physical mode. Hope to attend the upcoming conference in physical mode. Thanks, sir.
Thank you so much, sir. Thank you.